Okay, we want to take a look at multiplying rational expressions, just a fancy way of multiplying fractions that contain polynomials. And notice here that we're multiplying fractions. So what we have is a bunch of multiplication and division going on, right? Fractions are division, multiplication of course is multiplication. Well, those two things work very nicely together because they're just inverses of each other. So for that reason, it would be useful if we could turn these polynomials into multiplication as well. In other words, factor them if we can. Okay? So the first thing we're going to do is factor all the polynomials. And I'm going to go through it. I'm not going to talk about the factoring here. I'm just going to do it. If you need to pause and double check everything, that's fine. Let's see. That'd be x minus 1, x plus 4 times 2 times x plus 1 times x minus 1 over x plus 1 squared. And so that's what we have when we factor. And we know from just basic fraction properties, if you multiply fractions, you just go straight across. You multiply straight across. Notice that I couldn't factor my x plus 1. There's nothing I could do with that. So now I'm just going to multiply everything across, and I'm going to take this x plus 1 and put it in parentheses because it's going to be multiplied by everything on the top of the second fraction. So I've got x plus 1, and I'm purposely going to put a dot between everything. So x plus 1 times 2 times x plus 1 times x minus 1. I don't want to give the illusion that these three things are tied together. They're just multiplied as well. So now when you look at this, you can say, oh, okay, I just have 4 individual things multiplied. That's useful to think about that way. You don't have to write it that way. I'm doing it here just for explanation purposes so you can understand what's happening and get past maybe some preconceived notions there. So on the bottom, you know what you're going to get. You have x minus 1 times x plus 4 times x plus 1. You could write squared. You could put another x plus 1 since that's what x plus 1 squared is. And now you can see that the division here from the fraction can undo any multiplications because on top it's all multiplication on the surface, and on the bottom it's all multiplication on the surface. So this division can start undoing things. So for example, I can divide x plus 1 by x plus 1, and those will become 1s. I can do that again. X plus 1 divided by x plus 1 is 1. X minus 1 divided by x minus 1 is 1. And so now, simplifying this, on the top, 1 times 2 times 1 times 1 is just 2. And on bottom, 1 times x plus 4 times 1 times 1 is just x plus 4. And now we wonder if we can go further here. Sometimes people think, oh, this 2 and the 4 will cancel, but they won't because the bottom is addition and not multiplication. This fraction bar, this division, could only undo multiplication, and unfortunately on the bottom we do not have multiplication. So this is what we get if we multiply these two rational expressions. So it was key to factor everything because we need multiplication and division to work nicely together, and factoring creates multiplication.